In this video, we will be discussing the graphs of the cotangent function. For cotangent, since it is the quotient of cosine over sine x, or basically 1 over tangent x, and that sine x is an odd function, cosine x is an even function, it follows that cotangent x would also be odd, as you can see in the graphs here, where it crosses the x-axis. You can see in this graph here that the red graphs are for the tangent and the blue graphs are for the cotangent. Since tangent and cotangent are reciprocal functions, what you can basically do is whatever the y values of tangent are that you obtained, just get the reciprocals of those to obtain the values of the cotangent function. Also, what you can notice is that for the tangent functions, the vertical asymptotes are located at pi over 2, negative pi over 2, and repeating at every period. Whereas for cotangent functions, the asymptotes are 0, pi, 2 pi, and so on. For the properties of the cotangent graphs, for the form y equals a cotangent of bx minus c plus d, a is important in solving for the stretching or compressing factor, similar to the tangent function. For the period, it's p is equal to pi over the absolute value of b, and then for the vertical asymptotes, bx minus c is equal to 0 and bx minus c is equal to pi. These are for the consecutive vertical asymptotes for the given period. For the domain, it should not be equal to the value of the vertical asymptote plus the period times k, where k is an integer. For the range of the cotangent functions, they're from negative infinity to positive infinity. For the phase shift, it's c over b. And for the wiggle point, or the vertical shifting, it's at y equals d. So let's start with this example. First, let's write the coefficients or the constants. So a, b, c, and d. So in this case, a is 3, b is 4, c is 0, and d is 0. So that means for the stretching, you have the absolute value of 3, or simply 3, and then the period is the same as the tangent, pi over b. So in this case, it's just pi over 4, and then let's already divide the period into 4 for the graphing. So interval would be period over 4, or simply pi over 4 divided by 4 is pi over 16. Now for the phase shift, there's none. For the wiggle point or vertical shift, this is y equals 0. So let's solve for the vertical asymptotes. For the vertical asymptotes, bx minus c is equal to 0 and bx minus c is equal to pi. So in this case, 4x equals 0 and 4x is equal to pi. Therefore, x is 0 and x is pi over 4. Let's just box this to remind us that these are vertical asymptotes. And then maybe we could already start drawing x is 0 and x equals pi over 4. So let's say that this is x equals 0 and then pi over 4. So let's say 1. So let's say this is x is pi over 4 is one of the vertical asymptotes. The other one is x equals 0 is a vertical asymptote as well. Now, you know that the interval is every pi over 16. So that means this one, the first one, would be pi over 16. Add another pi over 16, that's going to be pi over 8. Add another pi over 16, that's going to be 3 pi over 16. Add another pi over 16, that's 4 pi over 16, or basically pi over 4. So what I would do here is that this would be the x. So now that we have the values for x, now let's go to the values of y. Similar to tangent, what I usually do is this. I look at the middle value. Pi over 8 times 4, that becomes pi over 2. Tangent of pi over 2 is 1 over 0. It becomes undefined. However, since this is cotangent, 1 over 1 over 0 is 0. Let's go to the left. Pi over 16 times 4, that's pi over 4. Tangent of pi over 4 is 1, therefore the cotangent is also equal to 1. So the value here is positive 3. 3 pi over 16 times 4, that becomes 3 pi over 4. Tangent of 3 pi over 4 is negative 1, therefore the cotangent is also negative 1 multiplied by 3, that's going to be negative 3. And then, as you notice, similar to tangent, this one becomes bigger, and this is undefined. This undefined actually goes to positive infinity. This one is also undefined, and this one goes to negative infinity. So if we plot these, it's gonna be at 0. So 1, 2, 3. So at 3 pi over 16, that's negative 3. Pi over 16 is positive 3. Something like this. This is the graph. Okay, so let's write the domain and the range. So for the domain, I can safely say that x cannot be 0 plus the period, which is pi over 4 times k, where k is an element of the integers. Or if you want, you can just try. When k is 1, it's going to be pi over 4. When k is equal to 2, it's going to be pi over 2. So it's at that interval. And then for the range, it's from negative infinity to positive infinity. So if I ask you for one cycle, the domain would be from 0 up to pi over 4. This one. So it's this graph. So for this example, let's write the A, B, C, and D. This one is 4. The B is pi over 8. The C is pi over 2. And then the D is negative 2. So in this case, the stretching is basically 4. The period is pi over B, which is pi over 8. This is simply 8. The wiggle point is y is negative 2. So basically, this is your vertical shifting. That's 2 units downwards. If I ask for the phase shifting, it's C over B. So it's going to be pi over 2 over pi over 8. Phase shifting is actually 4 units going to the right. So let's solve for the intervals. Intervals is actually period over 4. So that's 8 over 4. It's every 2 units. Let's solve for the vertical asymptotes. For the vertical asymptotes, pi over 8x minus pi over 2 is equal to 0, and pi over 8x minus pi over 2 is equal to pi. So here, I can say that pi over 8x is simply pi over 2 multiplying everything by 8 and then dividing by pi. This is actually equal to 4. This one, pi over 8, is equal to 3 pi over 2. Sorry, there's an x. X is equal to 12. My vertical asymptotes are x equals 4 and x equals 12. Alright, so let's count 1, 2, 3, and 4. This is one vertical asymptote. X equals 5, 6, 7, 8, 9, 10, 11, 12. This is the other one. Now, in plotting the x and y values, I will start with the first vertical asymptote, which is 4. I'll end up at 12. So, since the interval is every 2, this is going to be 6, 8, this is going to be 10. And then let's plug in 4 times pi over 8 is pi over 2 minus pi over 2. That becomes 0. Cotangent of 0 is actually infinite. Minus 2, it's still infinite. So, this is undefined, which is actually going to positive infinity. And then, at 6 times pi over 8 minus pi over 2, cotangent, so that's 1 times 4 is 4 minus 2, gives us 2. At 8, pi over 8 minus pi over 2 is 90 degrees. Cotangent of 90 degrees is 0 minus 2 is negative 2. And then at 10 pi over 8 minus pi over 2, cotangent, that's negative 1 times 4 is negative 4 minus 2 is negative 6. And lastly, at 12 pi over 8 minus pi over 2, the cotangent of that is negative infinite. Minus 2, it's still negative infinite, so it's undefined. So this one goes to negative infinity. So let's try plotting. So negative 6, so this is 2, 4, 6, 2. So let's have every tick mark 2 units. So at 4, it's undefined. At 6, it's 2, so it's this. At 8, it's negative 2 in here. And then at 10, it's negative 6, so it's this. So the graph would be something like this. So you will notice that this is the wiggle point, y equals negative 2. So to summarize, what's the domain? The domain here, x cannot be equal to one of the vertical asymptotes, 4, plus the period, which is 8k, where k is an element of z. And then the range from negative infinity to positive infinity. And then for one cycle, the domain would be from 4 up to 12. Both are open intervals. So it's this one. You can see the asymptotes are negative 4, 4, and 12, similar to what we have. We have 4, and then we have 12. And then if you add another cycle, you'll have some graph here on the left. And then you add another cycle on the right, you'll have some graph on the right. So these are more examples. Good luck and happy studying.